Okay, so till now we have installed PyCharm IDE and we have seen how to execute the Python code in the PyCharm IDE. Now we will see how to implement the PyCharm project in PyCharm IDE, like machine learning project on PyCharm IDE. What are the files that we need to create and what are the good steps that proper steps that we need to implement while working on machine learning project. So I will explain step by step process, what are the steps involved in building any machine learning model, and based on that particular step what files and project structure you need to follow. Okay, so first I will explain all the steps in machine learning project. So step number one is problem statement. Okay, so first we need to identify what is the problem statement, whether it is classification problem, regression problem, or clustering. But let's say if you are working on some different project like deep learning or anything, so first you need to identify and state your problem statement. Okay, second step, once you know the problem statement, then you need to read the data or load the data. Okay, so in machine learning we generally use structured data. In deep learning you can use unstructured data. So in second step you will load the data that you want to use for your project. Then third step, once you load the data, we generally start with EDA to understand the basic visualization and understand the data, like what type of columns and distribution of the data features we have. Once we are done with the EDA, then the fourth step is feature engineering, feature pre-processing. Okay, so in pre-processing what we generally do, we transform the data into numbers. Let's say you have one particular feature, city, so you cannot directly pass city data into the machine learning model because those models are numerical functions, like mathematical function. So it takes only numerical data in your it will take only numerical data for your model. So for that you need to convert your data into proper numbering format. That is one step in feature pre-processing. You can also convert your data into a min max scalar format to reduce the bias nets towards high variable. That is one more step. And then you can also check missing value and impute those missing values. So there are n number of feature pre-processing steps in machine learning project. So once you are done with the feature pre-processing, or then you can do feature engineering or feature selection. Okay, so generally these steps can be like, you can do feature selection first, then feature pre-processing and all, it's totally fine. So in feature selection what we do, we identify the important feature. Like let's say I have set of 10 variable, so from those 10 variable I will select 9 important feature, rest 1 variable I will not use because it is not useful for this particular problem statement. So to identify those features, which features are important and not, you need to have basic common sense and domain understanding. But let's say you don't have any domain understanding, then you can consult with a person who has domain understanding for that particular data set. So you can use common sense and basic understanding, and also you can use feature pre-processing and technique to identify which features are important. Once you are done with the feature pre-processing, then next step is data splitting. So in data splitting, we generally split the data into 80-20%. 80% we will use for training, rest 20% we will use for testing data. So we write the code for data splitting, and once we are done with that, then there are few more couple of steps, but I'm at this stage I'm just explaining the high level process. Okay, then in 7th step generally we start model building. Now after model building we evaluate the model performance. Okay, and for that we can generally use confusion matrix, classification score, accuracy, classification report and accuracy. And once let's say we build 2 model, logistic regression and random forest, and we evaluated both the model. Now after this we will before model evaluation you also need to do, so 8th step will be model prediction. So after model prediction only you will evaluate the model performance, because you will have predicted data from the model. You will compare that predicted data with the ground truth, which we already have in split data part. So once you evaluate the model performance, which is 9th step, then what we will do, we will compare which model is giving a good accuracy. So 10th step will be comparison. Now in this part, in comparison, so basically in model comparison, what we are going to do is, let's say we have two model, logistic regression, then random forest, and SVM, support vector machine algorithm. So we will compare accuracy report, accuracy score, classification report, and other stuff. And from that we will select one model based on precision and recall. So there are n number of steps involved in model comparison. And after that, once we finalize one model, then we will use that particular model for, so let's step 10, 11 will be selecting the final model. And once we are done with the final model, then we will save all the objects into local disk. So let's say object means your standard scalar, then then label encoder, whatever you are using, and the model. So we have trained the model on trained data, and we have evaluated the model performance. And logistic regression, for example, let's say random forest is working good compared with all the two models. So what we have to do is we have to save all the object, like your trained model and the object that you have used to scale the data, and label encoder to encode the data into numeric format. So all these objects you need to save on your local hard drive using pickle object, or you can use joblib also. That I will explain later how pickle and joblib works. And once you are done with that part, then next step is creating inference pipeline. So inference pipeline is nothing but a function where you will pass the raw data, and entire step, like starting from converting raw data to proper numeric format, standardization, scaling, passing to the model, getting the prediction, all these steps you will implement inside the inference pipeline function. So you can consider inference pipeline is a function where you will pass the raw data, and that function will return the final prediction, because that inference pipeline we are going to use for the deployment. Okay, so creating an inference pipeline is important step. Okay, once we are done with inference pipeline, then 14th next step will be creating an API. Now API is an application programming interface. We will deep dive into the API part as well, like what is API, how to use. But once you are done with the inference pipeline, we have to create an API so that request can raise a proper request to your model. Then your model will return a prediction, and that prediction will go to the user as a response. So this is a request and response thing that we have to use inside the API. Okay, so once we create the API, then if you want, you can create web UI also, means user interface. So to create a user interface, we have n number of options. For example, Gradio, then web application using HTML, CSS. You can also use Streamlit. So there are n number of basically options to create web interface. Okay, so these are the steps that are involved in machine learning project. But typically these are the steps involved in all the project. Like go with any deep learning or any other project, you will mostly use this kind of step only when it comes to model training. Now let's say you will going to use all these steps for your machine learning model. So based on this step only, you have to structure your entire code into a proper PyCharm, into a proper format. And to create that format, we are going to use PyCharm IDE. Okay, so let's say you are working on this particular project. So how you will structure your project? So let's say you have created the entire project into the Jupyter notebook. So let's consider this is your Jupyter notebook, and this particular block is for step 1, where you will load the data. Then once you are done with step 1, you will work on step 2. So there will be another block inside the same Jupyter notebook. This is for, let's say, feature selection. Then step 3, then step 4, and then step 5, then step 6, then 7, then 8, and so on. Okay, so you have one Jupyter notebook where you have implemented all the steps starting from step 1 to last step 15, 16, whatever it is. Now the problem is, if you create this kind of Jupyter notebook, you won't able to deploy that on production server, because on production we don't use .ipynb. So that's why we have to follow a proper Puppet standard, and we have to convert the .ipynb file into .py file. So what we are going to do is, we will break down the entire code into a .py file, but logically. For example, I will create one .ipynb file. Okay, so this is my one .ipynb, and this file will store all the config variable. Okay, then I will create one more file, again ipynb, and inside this file I will store data reading logic. Then one more file for feature preprocessing. Okay, once we are done with preprocessing, similarly I will create one more file for all the steps, and let's final, and I will also create one main.py file. Now this main.py file will use all the .py files inside the main.py file. So technically we will import config, data reading, feature preprocessing, all the .py file inside this main.py file. So you can consider for your project, main.py file is a driver script. So if you want to run this entire project, all you have to do is execute this main.py file so that it will start the entire project. So this is how you need to structure your entire project, machine learning project, into different .py file. Now I will explain that how you can do that using PyCharm. So let's create new project on PyCharm. Now I have restarted my computer. So you can see these are the packages which are not used inside this code file. So I can simply remove those packages, and A, B is not utilized. So let's say name is used inside this code. So let's say if I remove this part, then you can see it is highlighted that name is not defined. Okay, because we have not imported that particular part from config. But the moment I write name variable, okay, the error will be gone automatically. So that is the thing, when you use PyCharm, you get proper support of how to structure your code, and you will get hints if you are making any mistake before executing the code. So let's create one more project. So to create a project, you can go to this part and click on new project, and let's give new name to this project. Let's say ML project. So I will write machine learning dot project dot structure. You can give any name to your folder like ML project structure. Now let's create new Conda environment for this particular project. So I will start with generate new Conda environment using Conda. And for this particular project, let's say we will use Python 3.11 version. Name of the environment, again, you can keep similar to your project folder, ML project structure, that's it. And let's click on create button. Now I have already opened demo project on my PyCharm. So I have two options: open the same project in this window or create a new window. So as of now, we don't require this demo.project file. So I will click on this window. Okay, so it will open the new project on PyCharm IDE. And again, here you can see, first it will scan all the dependencies and it will create a new Conda environment for this project. Once this is done, then you can see whatever the project folder that we have created, we can see that it is populated at this particular location, this side. Here you can see no interpreter. After a couple of seconds, you can see ML project structure is present. So as of now, we have just created a folder, project folder, but there are no files inside this folder. Okay, so here we can see it is scanning all the Python dependencies, and it's a fresh, newly created Anaconda environment. So whenever you create a new project, first thing you need to do is create a config.py file. So let's create that new and go to Python file and create config. No need to mention .py, just type config, enter. So now we have created a config.py file, and inside this py file you can mention your model, like which model you want to use, all the configuration variable. Okay, so as of now I will create one variable logistic, and whatever hyperparameter that we use generally. For example, when it comes to decision tree or random forest, then there is a parameter called entry. So I will declare that here only, and then inside the main.py file, I will import this entry parameter from config file. So in config.py file, you need to create all the variables, hard-coded variable. Like basically you need to declare everything which you are going to hard code on your code part. So I have created config.py file. This is first step. Now we'll go step by step. So once you know the problem statement, second step, what we do, load the data. So let's create one more .py file, new Python file, and I will rename this file as data loading, enter. Now in data loading, what code we generally write? From import pandas as pd, and what other package generally we use? Import numpy as np, another package import matplotlib.pyplot as plt. Now you can see there is a red underscore, okay, this line. So this line is indicating that there is an error in this particular 3 import packages. So whenever you face such kind of issue, that means you need to import that package. So you can import the package using 2 ways. First, click on terminal and type pip install pandas. So it will install the pandas package inside your terminal, inside this Anaconda environment. Or else you can do this thing also. Keep your cursor on this red color underscore line, and you can see install all missing packages. Once you click on this part, it will directly select matplotlib pandas numpy and click on install. So you don't have to write that pip install command on terminal. It will directly import all these three packages. Okay. But as of now, you can see that at this part, you can see installing packages. Okay. So it will install numpy, pandas, matplotlib, because that I have already selected. And once that is installed, it will again scan all the packages present inside this particular environment, and then the error will be gone automatically. Okay. So we need to wait for a couple of minutes. Till then, I will write code. So to read the data, we just need to use df pd.read_csv. Okay. And inside this, we need to mention the file path. Now I will write file path in capital. Why? Because I will declare this file path inside my config variable. So as I said, all the variables that we need to hard code, you can just declare that here. So I have one data folder. Inside that data folder, I have ML like loan. Let's say I will write name of the file, like I have a CSV file, loan underscore prediction.csv. Okay. So this is my loan prediction.csv file, which I want to use for my project. Now this loan underscore CSV prediction CSV file is present inside the data folder. So we need to create one data folder inside this folder structure. So right click on new and select directory. So once you select directory, you need to type a name, data, enter. So whatever data you have for model building, like train file, test file, you can keep all those data file inside this data folder. And later on, you can just mention the file path in this config.py file. Like what is your train file, test file, and prediction file. So maintain a config.py file with all the variable. Keep your data files inside the data folder, and then inside the data loading, you can just import from config import star. So when I say star, star means import all the packages which are present inside the data, inside the config variable. But if you don't use star, then it will, then you have to import each and everything one by one. So sometimes, let's say in config variable, there are hundreds of variable. So you have to write all the hundreds variable. So what you can do, instead of writing all the variable name, just type star. Okay. Now, no module name, pyplot. Okay. I guess I have done spelling mistake. Okay, let me change. Now see, so in this particular code, I am using only pandas library. I'm not using numpy and matplotlib. So you can just remove this particular part. Okay, so I have created a data loading file where I'm using the data, I'm reading the data. Once we load the data, then what next step we do? EDA. Okay, so I will write data underscore visualization. Okay, now whatever the EDA code that we have written, like creating scatter plot, then distribution plot, bar chart, count plot, pie chart, all the code for visualization you can write here. Now in Jupyter Notebook you can plot your data, but in PyCharm you cannot plot. So you need to save that file as an image. So for that I will again create one more folder. Go to new directory, and here I will name this directory as plots. So inside the plot folder I will keep all the plots that I will use, that I will create using data visualization. Okay, once we are done with the data visualization, let's create one more .py file, and this will be data preprocessing. Now inside the data preprocessing only you will write the code for feature selection and feature engineering. So whatever the code is required for those steps, you need to declare that inside this particular code, but in a proper function format. Okay, you don't need to call anything inside this file, just declare all the functions. Once that is done, then the next part is model building or data splitting. So I will create data splitting.py file, and here you will split your data, and then after data splitting we will write model training. Okay, once we write the code for model training, then next step will be model prediction. Okay, and after model prediction we need to evaluate the model performance. So for that I will create one more file, new Python file, and this will be model evaluation. Here I will write all the code for confusion matrix, classification, score and all. Once that is done, I will create one more file, and this is for, let's say, deployment or inference pipeline. Okay, so here I will write the code for inference, and after that I will write one more file for model deployment. So all the deployment related code I will write inside this code file using Flask API, and then the final file will be app.py file. So inside this app.py file, I will import all the code from config, import star. So import all the configs, then from data loading, import star. So basically all the steps that you have declared in each file, data loading, data preprocessing, splitting, you need to call all the functions inside this app.py file and run only app.py file. So the moment you run this file, it will train the model, save those objects, and it will trigger your Python code. Okay, and to save those model, you need to create one more directory, models. So here you will save all your trained models. Okay, now after that what you can do is create one more file, which is readme.md file. So for that you can select on file readme.md, and inside this readme.md file you will write the entire documentation, like what is the heading of your project, then what will be the subheading using double hash, and then your problem statement, objective, and what are the steps that needs to be done to work on this particular project. So readme file is like a instruction manual for your entire project, so you need to maintain that thing. And one more important file, which is requirement.txt file. So inside the terminal you can type pip list requirements.txt and enter. So it will create requirement.txt file, which will have all the packages. So if you go to requirement.txt file, you will see these are the packages which is required for this particular project. So this is the folder structure that you need to follow while working on any kind of project. So create a data folder where you will store all the data, model folders to save all the save object like models, scalar object and encoder object and all. Plot folder you will use to create to store all the images, and rest of the .py file will be used to declare the code based on the logical level, and you will use one driver script to run the entire project. And readme.md file will be your instruction manual, and requirement.txt file will be the file where you will note down all the packages. So this is the folder structure that you need to follow.